Homework M1, question 3. Once again, we've got a lot of information to describe what's going on with the non-uniform rod and all the various masses in it. We've got a diagram which I've done some amendments to. We know that we have a mass of 5/2m placed on the rod at point B, which I've labelled here, and our point G, labelled on our diagram, is where the centre of mass of our non-uniform rod is, but we don't know where that is. Now we're asked to find the distance GD, so I've called that distance x. We're told that this rod is on the point of tipping about D, which means that there is no reaction force at the point C. Now if I take a moment around D, that will also eliminate RD from my problem, and that leaves me only with X, M, G and D in my problem. So taking clockwise forces, this gives me D times 5/2 mg is equal to anti-clockwise forces X mg. If I eliminate mg from both sides, this gives me quite simply that my distance x, which I need to find, is 5/2d. In part B, our mass is moved from point B to the middle of the rod. The rod remains in equilibrium, so I have amended my diagram. This time neither of our reaction forces are 0, so we have RC and RD to deal with, and so I've got 3/2d between each side of my mass 5/2 mg. We are asked to find what the magnitude of the normal reaction between the support at D and the rod is, therefore we need to find RD. We're going to create simultaneous equations. If I resolve vertically, I get RC plus RD is equal to mg plus 5/2 mg. And so I'm going to make RC the subject here of this equation. RC is equal to 7/2 mg minus RD. And then I need to take moments around a particular point, and the one that I'm going to take moments around is D. Now, that might seem odd because that's going to eliminate RD from my equation, and that's what I'm actually trying to find. But the reason why I made RC my subject is because if I eliminate RD, I only have something in terms of RC, and I can substitute in for RC and get something purely in terms of RD. There are other ways of doing it. This is the way that I've chosen to do. So going clockwise from D, then I have my whole distance here of 3D times reaction at C, RC, and then going anti-clockwise I have 3/2D times 5/2 mg, and I also have 5/2D times mg. Now every one of those terms has got a d in it, so I can eliminate those. And now I can substitute in for RC, and I have 3 lots of 7/2 mg minus RD, and that is equal to, if I do the multiplication, 15/4 mg plus 5/2 mg, but if I want to be able to add these, I could write that as 10/4 mg. So, if I combine these right hand side, I have 25/4 mg, and if I expand this left hand side, and again I want to write it as a fraction over 4 to make my work easier, that's 21/2, which is 42/4 mg minus 3 RD. Rearrange that. 3 lots of RD is equal to 42 minus 25/4 mg. So 42 minus 25 is 17. And then if I divide 17/4 by 3, that actually becomes 17/12 mg for my value of RD.